Hello friends, welcome back. In the previous tutorial, we have learned the difference between procedure-oriented and the object-oriented programming paradigms. Then we have seen object-oriented programming concepts, how they are beneficial. In this tutorial, we are going to get some information about UML. Now what is UML? UML stands for Unified Modeling Language. It is a standard way to model or design variety of software systems. Unified Modeling Language is a set of specifications provided by Object Management Group, OMG. If you want to know or get more information about UML, then you can go to their site and get some more information. In this tutorial, we are going to get some information or preliminary information, you can say, for designs. So UML is a visual modeling technique. You can say this is a standard way to model or design variety of software systems. UML, it is used in designing smaller systems to the larger enterprise systems. UML has a set of diagrams and notations which help to represent the different designs, you can say. UML is used to create architecture or represent the architecture of the software. There are many other reasons we see step by step. Now, how we use UML diagrams in games or UML in games? Now, we use UML diagrams in games at the pre-production step only. That means before producing the game, that means before start developing the game, before writing the code, before bringing the assets, creating the assets, all those things. What we do means once we get the idea, we can start sketching that game idea using the UML. Start sketching, graphically represent your idea using the UML. We use UML to represent game objects and the relationship between game objects, how they interact, that is interaction between the game objects. And even we can use UML diagrams to show the complete game architecture, interaction between the modules or subsystems in the game, interaction between there are many different diagrams we have in UML which we can use to design the game, which is really useful. You can say if you design before development, you can reduce a lot of difficulties, like you can reduce errors, you can reduce bugs, you can reduce the maintenance problem. There are many other issues that you can reduce before. UML is kind of a planning, you can say. Before developing a game, you are going to make a plan of the game by designing the different diagram. Now UML, the basic element of UML when you come to object oriented programming, that is the class diagram. A class diagram, you should know how to draw the class diagram. That is important. There are many other diagrams we have in UML, like use case diagram, integration diagram, activity diagram, sequence diagrams. There are numerous diagrams are there. I suggest you people to learn UML diagrams, how they are drawn, how they are used in games. But anyhow, step by step, we are going to learn different UML diagrams, how to draw them. Maybe in future, while developing games, first we draw the UML diagrams and convert those UML diagrams to the games and see how they are beneficial also. Let us check it out. Step by step we learn. Now first of all, we need to know, as I told, class diagram, how you are going to draw. This is a class diagram. I hope you guys remember that when we were learning first time how to create a class, identify the entities in the problem domain. We have drawn a class design before. If you remember that, it's good. If you do not remember, here once again I am going to talk about it. Now the class diagram that you see, a box. If I want to represent a class, we are going to use a rectangle box which is of having three compartments. Compartment 1, compartment 2, compartment 3, you can say, or you can say a rectangle is divided into three parts. The topmost part is meant for writing the name of the class. So in this place you are going to write the name of the class. Then here you can see we are going to use two left arrow and the right arrow symbols. In between that, or we can say that we are going to tell what is this name. This is here we write a class name. If it is a structure, then we write here structure name. If it is an abstract class, we write that abstract class name. If it is an interface, we write here interface name. Then just above that name, we have to write in these angle brackets, you can say you have to sandwich what is this name indicates. This is a class, then we write here class. If this one is a structure, we write here structure. If this one is abstract class, we write here abstract. If this one is an interface, then we write here interface. Let's take an example. If you want, I just go to the whiteboard here. If I need to draw, let's take an example of point. I want to represent a point class. Then we are going to draw a rectangle box like this. Then the first part is for the point. As I told that we are going to write point. Now this point is the name of the class or maybe structure. According to that, you need to write here at the top. If it is a structure, we are going to write structure. If it is a class, then we write here class. That indicates that this point is a class. Then we write the next part is for the fields or attributes of that class, you can say, or properties we are going to list out. As we know that every point is going to have the x and y positions, right? X and y. If it is a 3D point, x, y, z will be there. Here you can see that if you need to write the fields, first you need to prefix the symbol either plus or minus or hash or tilde. These signs you can prefix before the field name. Now this sign plus, minus, hash and the tilde indicates separate meaning. There are different meaning for them. What is the meaning of that? They actually indicate the visibility scope of the variable. We understand step by step. Already we know what is public and private. Public members are having the scope of accessibility, anywhere you can access them, whereas private members can be accessible only within the class that we have seen. In C# we have different access modifiers. We have a public, private, even we have a protected. There is another other two access modifiers are there. They are internal and protected internal. We see them anyhow step by step, don't worry. But here most important thing you need to remember is the plus sign indicates if a member is public member, then you should prefix that member by plus sign. If a member is a field, member means a field or method. You can see here while writing the methods also we use the signs. So a member is a private member, then you need to prefix it by minus sign. Then if a member is protected, then you need to prefix it by hash symbol. If it is assembly level, package level member, then we have to use tilde. Now the assembly level or a package level means in C# we have internal. This package level actually we use in Java, we use packages. That is not necessary at present to understand, but at present you remember that assembly means in C# we can say a namespace. Within the namespace you can access anywhere that member. That's the meaning of that. So at present let us come to this diagram. We have x and y fields. X field, let's consider x as well as y are publicly accessible. So what we do, we write plus sign that indicates this member is public. Then we write the name of the member, that is x, field name x. Then we put a colon. Then we write the data type, what type of data it is. You can write here it's a float type. Then plus y, then I say here float. Here you can see that this is how we list out all the fields of that class. If it is a private, public, protected, all the members we list out. You need to remember these signs. What is the meaning of plus sign? What is the meaning of minus sign, hash and tilde? Once we list out the attributes or properties, that compartment is done with. The next one is next compartment is meant for the methods or the behaviors. You are going to list out all the behaviors. That means how do we write the behavior? What I do here, in the point class, if you remember, we have written a method with the name as getDistance method. GetDistance method is a public method, so we write here public, that is plus sign. Then we write the method name, so getDistance is the method name. Then parameters, if any other parameters are there, you need to write there, parameter list. So parameter list, we know that it takes other point, just other point, just you need to say other point, bracket close. That is the parameters list. Then you can put a colon If it is returning anything back, then you need to write a return type. If it is not returning, I can just say here void. You can see that we just now designed a first UML class design. So I hope you guys have understood how, right? I hope you guys have understood how do you design a class and understood what are these signs, how do you create a complete design. If it is a structure, then of course you need to just take this, if it is a structure, you have created a point structure instead of a class, then I can copy paste this one somewhere else I can put. Then only difference you need to modify now is you need to remove this, because it's not a class now, right? It's a structure. So you can use you can write here struct 2 angle brackets. That indicates the point is a structure. Oh, excuse me, here I have not written CT. You should write CT also, struct. This is how you design a class. Now when you draw a class diagram for a complete game or a larger application or a software, then it is not possible to represent the complete class diagram with the properties and fields, everything. Just at that time what we do means only we write a rectangle box, and inside that we write the class name. That indicates, the rectangle box actually indicates the class in UML diagram. So this box, what you see here is a class. This is a class A, and there is another class called B. There are two classes we have here. You can see that the icon that you see, that I have drawn a line from here to here, then a empty triangle I have drawn here. That symbol, the symbol that you see, the arrow symbol, that indicates that inherits. It indicates the inherits. That means B inherits A. You have to read like this: B inherits A. Understanding? Now here you can see there is a class A, there is a class B. Here this A is not a normal class, it is actually interface. We understand what is interface and all later, step by step. At present you understand that here A is interface, consider that one, or assume, you can say. Now B implements, you have to read it as B implements A. When you see this diagram, that is the dotted lines will be there, and at the end you will be having a triangle. That indicates that B implements A. So icons, you need to differentiate these symbols. This you can say it's not a dotted line, this is a dotted line. Whenever you see dotted line, you read it as implements. You have to read from tail to the head. B implements A. Similarly here I need to read it as B inherits A. Understand these things. Now the inheritance, we are going to soon learn what is inheritance in depth. Now inheritance indicates is a relationship between the objects. It represents the relationship between objects. As I told that, you can see UML diagrams help us to represent the relationship between objects. You can see, you can say here B is a, you should read it like this: B is a. You can read it like that, but no problem. I will explain you what is a relationship, how it is available in the real world, or how you can identify there is a relationship between your game objects. Let's proceed further. The next thing is this symbol. You will be having a straight line and just an arrow mark. This is not a triangle, you can see that, just a direction symbol like a vector, you can see that. This symbol indicates uses icon, or you can even say has a relationship. This uses, the use a symbol indicates that has a relationship. There are two different relationships we come across in between the objects. We come across two relationships, is a relationship and has a relationship. We understand what is the difference between is a relationship and has a relationship in depth, step by step. Now at present you can say that B, you should read it like this: B uses A, or you can read it as B has a, or you can say B has A, like that you can read. Now if I have to tell a general example for is a relationship, you can say, take an example of a bird. Now we have a bird class, let's say we have a bird class, and then I can draw a triangle and I can say here a parrot. Now parrot is a bird. This is a relationship between parrot and the bird class and the parrot class. We understand step by step. There are many such relationships we find in real world also, even in softwares like let's take the manager. If I write here manager, and here if I write employee, we can say that manager is a employee. That is a relationship. Then in your game object also, in your games also, you can say like let's take an example of a zombie. Now zombie is a enemy, right? We can create an enemy class. There will be a class called zombie, and we draw a diagram something like this to indicate the relationship between enemy and zombie class, and we can read it as zombie is a enemy. Simple. Or even we can say as zombie inherits enemy. Simple. And there are some other examples for has a relationship. Now has a relationship, if I have to say an example for has a relationship is let's take an example of a cop. Now cop is a police, a police. We can say that he uses gun. Now there is a class called a gun. We can draw like this, and a cop. This is C cop. Now we can say that cop uses gun. So this is uses, or you can say cop has a gun. Even there are many other examples that you find in games, like every game object is going to have a position, right? Every game object is going to have a position. So you can game object has a position. You can see that in English only I am telling very easily that a game object has a position. So how do we draw that one? Has a relationship. So I can say position is a vector 2D structure or a vector 3 structure. Then there will be a game object class, and we draw a straight line from here to here, an arrow mark. Then we can read it as game object has a position, right? That is has a relationship. I hope you guys are understanding. There are many UML diagram tools available on the online. Please download those UML drawing tools. Like there are softwares like eDraw. There are different softwares are there. I suggest you people to go and download and try to draw different UML diagrams for different any application. You can take any example of the real world and start drawing those. If you can able to find out is a relationship, has a relationship in them, and start drawing, that will help you out for any other applications to draw or represent any other architectures, you can say. So let's proceed and get some more examples. Here we have a class and objects. Now we have learned what is a class and what is object. Class is a blueprint or a design for instances or objects. Objects are real world entities which are also known as instances of the class. And when we got the problem of finding the distance between 2 points, first we identified the instances, that is P1 and P2, and we know that both are points, so we designed a point. We have drawn a class design for the point in the previous tutorial. Here you can see that actually we should draw something like this instead of drawing like this, but this is a generic diagram. You can see I have not used a plus sign, I have not used the data types and all those things, but it's almost similar. You can see left and right here, and you can see that the class design. Here you can see that we created the point design. Then we identified the properties of or common properties of the instances, like P1 has XY, P2 also has a XY. Instead of writing like this individually, like float X, float Y, float X, float Y for P1, P2, and to get the distance we need to pass 4 members X1, Y1, X2, Y2, right? That will make our code cumbersome and not much manageable. So we need to take the help of object oriented programming principles to manage our code efficiently. So what we have done, we took a help of encapsulation. So encapsulation means grouping the data members and the member methods in a single unit, that is a class in object oriented programming. So we first created the design, right? We create a point design, and you can see at the top we have written class, and then we identified the members. We kept here x and y, and we return everything properly. Then we identified the get distance. Once we get the design, the next thing is to convert it to the code. And one of the most important thing, you can see that encapsulation already help you to reduce the number of lines of code. If you have 200 points, then you might needed to write 200 times this float x1, float y1, float x2, float y2, float x3, float y3, so on up to float xn, float yn. So 100 times you need to write those things, and you need to pass to the get distance appropriate xy components to find out the distance between those points. But that is more difficult. Instead of that, we can create a class and put the common elements or common attributes and behaviors in that class, and later you can create the instances very easily just by saying point p1 equal to new point p2 equal to new point. You can create n number of points, and you can manage the objects very easily, right? So here you can see that we can create a point p1, and every point you can say p1, p2, even pn, every instance is going to have the same fields and same members. That means you can think like all the instances are going to inherit the properties and behaviors from the point class, right? So here also we have a little bit kind of a inheritance concept thing. That means if we have n instances, p1, p2 and pn instances, we identify the common things and we create only one common place. We keep all the common behaviors, and every member is going to inherit those behaviors and properties whenever you create them. Kind of inheritance only. So class also helps you to put the common properties and behaviors of instances in one place. Understanding this part, you need to remember, class helps you to put the common properties and behaviors of many instances in one place. You can think like class is a factory for creating these instances. Now we understood a little bit. Next you can see here point p1, point p2. The p1 and p2 are actually called as references. That also you need to remember. p1, p2, p3, whatever the variables that you create by using the class, they are all references. References are actually implicit pointers. They hold the address for another point or another memory location. Here the p1 is just a reference. After that we write a equal to sign and say new point. What new point does? It creates a new instance. New instance means new object. It creates in the heap, right? With respect to the class, it creates in the heap, and then it returns the address, and that address, once we store in the p1 starts pointing to that memory location, that object, right? So object is in the heap. The p1 is just a reference pointer, points to that object. Now as we have equal to sign, we assign the address, p1 is pointing. Now this step, this complete one step is known as instantiation. Instantiating a reference with a point. We read it like this. Understanding? If you do not say new point, the point p1 is not an instance. Remember that. It's not an instance. It is just a reference variable. Instance is over here. Understood? Then, what are the advantages of encapsulation? How it helped us? Now, encapsulation advantages are efficient code management, protection of data. Protection of data means you can make the members private so that they cannot be accessible outside. You can make them public so that they can be accessible anywhere. You can control the level of access of data. That protection level you can build in the classes by using the encapsulation. And also you can see encapsulation helped us to put the common properties and behaviors in one place, in one unit. So it also helped us to reduce little bit redundancy, you can say, redundancy of code. So in this tutorial we have got some information about UML diagrams, a visual modeling technique. You can say Unified Modeling Language is a specification written by the object management group. It's a standard for designing different softwares. Even we use that in games. And it has set of diagrams like use case diagrams, class diagrams, integration diagrams, sequence diagrams. And these diagrams we can use to sketch the game ideas and represent game objects, relationship between them, how they are interacting, and what is happening, or you can say sequence of operations that are happening in the game. And we can even show the complete game architecture, that is the interaction between the modules and subsystems in the game. Then the basic unit of UML is the class diagram. We have seen how we draw the class design, how we create a class design, or how do we identify the entities and create later class designs. Then how do we write fields and behaviors, what's the meaning of plus, minus, hash and tilde. Then how do we represent, which symbol we use to represent inheritance, which symbol we use to represent implements, which symbol we use to represent users or has a relationship. And we have seen a simple example of creating the class design, and what is encapsulation, how it helps us to, what are the advantages of encapsulation, and what is a reference, what is the meaning of instantiation. Instantiation, important thing, remember this one. And we understood how encapsulation helps us to put the common properties and behaviors in one place, and later we create as many number of instances we want. We can create, all the members are going to inherit those common properties and behaviors. So for this class, this much is enough, friends. Keep learning, keep coding, keep sharing. Try to understand, watch these videos again and again, get more information online. So thank you guys, thank you very much. See you in the next tutorial.